question 2, we're given a lot of information, so we better start off with a diagram. We know it's projected vertically upwards from a point A, so let's label on that point A, and it's projected with a speed of u, so that's its initial velocity going upwards, and it goes all the way up, and we're told it moves freely under gravity until it returns back to A again. And we're told that the time for that entire journey back to A is 3 4/7 seconds. So we've got to start off by showing that the speed at which it was projected was 17.5. There's a bit more information we can put on the diagram. We know that the acceleration is going to be downwards at 9.8. We know that the velocity at the top will be 0. And I'm going to put my positive direction here as upwards. Okay, so if I'm trying to prove then that u equals 17.5, I'm going to use the Suvat data which I've got. The time I'm told is 3 4/7 seconds, and that's to get from the point A back to the point A again. So that's going to give me a displacement of 0. U is what I'm trying to figure out. I don't know anything about the velocity, but I do know that the acceleration is due to gravity, so it's minus 9.8. So I've got S, U, A and T. I can use S equals ut plus a half at squared. So subbing in those values, 0 equals 3 4/7 of u plus a half times minus 9.8 times 3 4/7 squared, remembering that it's only the t that I'm squaring, I don't square anything else. When I've rearranged that, it will give me the value I'm looking for of u being 17.5 meters per second. In part B, I'm going to draw myself a new diagram because I'm now looking for the greatest height. I'm not looking for when it gets back to A again. So to avoid any confusion, here's my diagram. I now know that the initial velocity is 17.5. I know that my final velocity up here is 0, and I know that I've still got acceleration due to gravity of minus 9.8. So we'll have a look at our Suvat data. S is what we're trying to find that greatest height. We know we're starting off at 17.5 if we're taking upwards as positive. V, we know at the greatest height is 0, and A we know is minus 9.8. So we're going to use V squared equals U squared plus 2AS. 0 squared equals 17.5 squared plus 2 times minus 9.8 times by S, and rearranging that will give you 15.6 meters. Part C, I'm actually going to draw myself a third diagram because the situation has changed again. I'm now looking for when I'm at 6.6, which is the same as 6 3/5 meters above A. So here I am at A. I'm starting off with 17.5. It's going to go up and come back down, but I'm only interested in this level here, where the distance above A is 6.6 meters. I know gravity is acting downwards, and I'm going to go for up being positive again. So we'll have a look from Suvat to see what data we've got available. We know that the displacement we're looking for is when it's exactly 6.6 meters above, because then we're going to find the 2 times of when it crosses that 6.6 meter line and then find the difference between them. So we're looking for the exact displacement of 6.6. We know we're starting off at 17.5. We know nothing about the velocity at that stage, so we've got to leave that one blank. And we know acceleration is still due to gravity. We're asked to find time. So it's going to be S equals ut plus a half at squared. And immediately we know we're solving that for time. We're expecting a quadratic. 6.6 equals 17.5t plus a half times minus 9.8 t squared. First step in solving a quadratic is to get all the terms onto one side and set it equal to 0. So rearranging that will give me 4.9 t squared minus 17.5 t plus 6.6 is equal to 0. Then I can use my quadratic formula because I know that that is going to give me A, there's B, and there's C. So the two values of t which will come out are 3.14 or 0.42. In this case you might be better off leaving them as fractions, 22/7 and 3/7. So the total time is the difference between these two, 3.14 minus 0.42, which should come out, if you haven't rounded it and got any errors due to that, as 2.71 seconds.